Hello everyone, I hope you're doing well. On this channel, I share videos that promote the importance of mathematical modeling techniques. In today's video, I will discuss the classification of natural numbers and the Collatz operation, both of which are presented in Chapter 2 of the first paper on the Collatz Conjecture that I published on Zenodo. When a natural number n sub I is odd, applying the operation 3 times n sub I plus 1 always produces an even value for n sub I plus 1. The following value, n sub I plus 2, obtained by dividing n sub I plus 1 by 2, can be either even or odd. Based on this distinction, I decided to divide odd numbers into two categories. The next table lists the odd numbers from 1 to 51. Those shown in bold represent the odd numbers for which the value n sub I plus 2, obtained by dividing the even number n sub I plus 1 resulting from the calculation 3 times n sub I plus 1, is also even. We define an odd number n sub I that gives even values for both n sub I plus 1 and n sub I plus 2 as a high-quality odd number, written as a. For example, when n sub I equals 17, both n sub I plus 1 and n sub I plus 2 become even. The general form of a high-quality odd number is given as follows. When n sub I plus 2 is even, the value becomes smaller, increasing the likelihood that the sequence reaches 1. Furthermore, for a high-quality odd number, the value n sub I plus 3 becomes either odd or even. When n sub I plus 3 is odd, we define this as a good quality odd number, written as a prime. In the table, the values of a prime are shown in bold. For example, in the case of a prime, the number 9 becomes odd in the following order. 9 plus 3. The general expression for a double prime is given as follows. When n sub I plus 3 is even, we define this as a better quality odd number, written as a double prime. In the table, the values of a double prime are shown in bold with an underline. For example, in the case of a double prime, the number 13 yields even numbers in the following order as n sub I plus 3. The general expression for a double prime is given as follows. Next, we define an odd number n sub I that gives an odd value for n sub I plus 2 as a low-quality odd number, written as b. In the table, these values are shown in normal type. For example, when n sub I equals 3, the value n sub I plus 2 becomes odd in the following sequence. The general form of the set b is given as follows. When n sub I plus 2 is odd, it becomes necessary to perform the calculation 3 times n sub I plus 2 plus 1. Again, because this gives a value even larger than n sub I, it is better for the sequence to contain as few low-quality odd numbers as possible if we want the values to reach 1. The classifications of odd numbers described above, together with their general forms, are summarized in the following table. Similarly, we also classify even numbers. The next table shows the even numbers from 2 to 50. For the values to reach 1 more quickly, it is better for the sequence to contain as many even numbers as possible. We represent even numbers by the symbol C. The general form of C is given as follows. Whenever one of the classified odd or even numbers appears, we must perform a different calculation depending on its type. Therefore, I define these procedures as Collatz operations and classify them in detail. First, we define the calculation based on a high-quality odd number, a, as Collatz operation A. Since a is divided into a prime and a double prime, Collatz operation A is also divided into two types. A high-quality odd number, A, gives an even value for n sub I plus 2, and this value can be divided by 2 again. The resulting value, n sub I plus 3, becomes either even or odd. When this value is odd, I define this calculation process as Collatz operation of prime. On the other hand, when n sub I plus 3 is even, we define the calculation process from n sub I to n sub I plus 3 is Collatz operation a double prime. The resulting value, n sub I plus 3, can be divided by 2 again. This makes it more likely for the values in this operation to reach 1. In later discussions, Collatz operation a prime and Collatz operation a double prime are sometimes combined and referred to simply as Collatz operation A. In this case, the number of occurrences, or the occurrence ratio, of Collatz operation A means the sum of the occurrences or the occurrence ratios of Collatz operations a prime and a double prime. When n sub I is a low-quality odd number, n sub I plus 1 becomes even, but n sub I plus 2 becomes odd. Therefore, we must immediately perform the calculation 3 times n sub I plus 2 plus 1, which increases the value. The calculation from n sub I to n sub I plus 2 can be written as follows. I define this calculation process as Collatz operation B. The classifications of Collatz operations A and B described above, along with their general forms, are shown in the following table. When n sub I is even, it must be divided by 2 immediately, as shown here. The resulting value, n sub I plus 1, becomes either even or odd. We define this calculation process as Collatz operation C. The classifications of Collatz operation C, along with their general forms, are shown in the following table. The classifications of natural numbers and the Collatz operations introduced in this video are essential for understanding the behavior of the calculated values in the Collatz conjecture, which will be discussed in the next videos. So please make sure to understand these concepts well. That concludes today's talk. I look forward to seeing you again in the next video. Until then, take care.